things that we would gain from them and that we wouldn't find otherwise. With that being said, I would like to introduce you all to our team. These people have worked hard for the past few weeks, and honestly, these sessions would not have been possible without them. So these people are Anushka, Bhagchandani, and Kapadia. Both of these will be hosting the session today and having a conversation with Mr. Jason Myers. Uh, the rest are Pallavi Vaswani, Harsh Navani, Prithvi Punjabi, and Vatsal Shah. I honestly am grateful for them to join us for this initiative, take this cause ahead. I thank you all for being a part of it. Thank you so much. And without further ado, I would like to introduce a speaker for today. Uh, and I honestly couldn't think of a better person to begin this initiative with. So he currently is working as a senior developer advocate for TensorFlow.js at Google and has been at Google for more than 9 years now. A thought leader at MIT Tech Review and a judge for CES 2020 Innovation Awards, he's Mr. Jason Miles. And he's here all the way from San Francisco, from a different time zone than we are. I am grateful that he's here, and this session will try to unfold a lot more about him, and we'll get to know him better within a few hours from now. And I thank you, sir, for giving us this opportunity, and we are truly grateful for it. Now I would like to hand it over to the other ideator, Harsha, to take it over from here. Harsh, to you.
Good afternoon, this is Harsha and I'll be serving as the co-editor for this initiative. And first of all, welcome to the Unfolded initiative. And secondly, I'd like to clear the code of conduct to you all and would request you all to follow that. Which is simple, switch off your audio and video. And if you have any questions, you can ask them in the chat box directly. And we expect you all to understand that we have students from all across India and working professionals from outside India as well. Plus, we also have our teachers, so we expect all of you to understand that the code of conduct needs to be strictly followed. Also, at the end of the session, we have our rapid Q&A wherein we'll ask your questions, your one to any, like whatever amount of questions you want to send, you can send it, and we'll try to get each and every question sorted. Before that, we have our Guess the Unfolder winner having this interaction opportunity with our unfolder, which is Mr. Jason Mears for this session himself. And the Guess the Unfolder winner for this session is Ms. Ananya Arora, and she will be getting a 5 to 10 minutes interaction opportunity with Jason sir himself. So without further delay, guys, I welcome you all and I present to you Unfolding with Jason Mears. Over to you, Kapadia.
So this is going to be a very informal and chilled out conversation with Jason sir. So we're going to try to talk about a little about TensorFlow.js, a little about his life at Google, and a little about his and get into his mind. So basically, we want to get out how he thinks and what has his attitude been, because that is what defines you, right? That is what makes you unique. So yeah, that's what we will go ahead with. So sir, could you just start presenting with your first slide?
Sure. Yeah. So I guess it's good to start with how did I end up where I am today, and a little kind of overview of my career history to date and the path I've taken. It's been quite an interesting journey. So I'm just going to go ahead and share a slide right now with you all. 1 second. Let me just do that. 15 years or so, if you include my work prior to Google, it's various startups, including my own. Yeah, essentially over half my life has been spent playing with JavaScript, and it's been an exciting journey, but maybe lots of learnings along the way too.
That's great. So now that we have a brief overview on your journey, so let's dig into it.
Sure.
So you graduated from the University of Bristol in 2008, and then you took up a job at Exmos Semiconductors. So you were telling me that there was something, some transition from your university to your first job. So
yes. So actually, it's an interesting story there. So before I graduated, I actually secured a job at an investment bank, and I'm not going to name any names here, but I did this back in September, and you graduate in like June or so in England. And upon doing the initial trainings and starting my first day, I realized this wasn't actually the environment I wanted to work in. So I actually quit that job on the first day, and that was a very scary process for me because, you know, I was a student with no money and no backup plan. But sometimes you have to follow your heart as well and do what's right for yourself. And I decided to go back to Bristol and just figure out what to do with myself afterwards. And that's actually how I got the opportunity to work at Exmos Semiconductor Company. And the old head of computer science of the Department of Computer Science and Engineering actually was looking for a web engineer for their semiconductor company called Exmos. They specialize in embedded parallel processing and all this kind of fun stuff. So I got to learn many interesting things there, actually. I got to wear many hats. Of course, I did the web engineering, but I also got to refine my front-end developer skills, my design, my UX, and even got involved in photography and multimedia production, and even 3D modeling in Autodesk Maya and all these kinds of fun things. So startups are really fun to get a wide variety of skills. I have a lot of responsibility early on. I was actually very grateful that my path ended up going this way, and I felt much more satisfied. So sometimes, I guess, the learning from that for me was that sometimes life presents you with scary decisions, and you've got to do what's right for yourself sometimes too. Definitely.
So then from Xmas, you transitioned into Google at a web engineer position. So what made you want to work at Google, and how did you make that transition?
So actually, just before I joined Google, I actually founded my own startup prior to that as well. This was just a web agency of sorts. There wasn't many people, just me and one other guy founded this company. And I was doing this alongside my Exmos semiconductor job as a web engineer. So from 9 a.m. to 5 p.m., I'd be doing my day job. And then from 5 p.m. to 11 p.m., I'd be starting my own company. And the reason I did that is because I didn't want to just jump and quit my current job and start a startup, because you need customers, you need some income coming in before you want to quit your actual stable job, right? So this was an interesting learning curve for me, and I think it's a good way to start things rather than just jumping off into the deep. But just as I was about to quit my semiconductor job to do my own company full time, I was a director of that company, I realized that Google had an interest in me. And I actually was never planning to apply to Google initially. It was one of their recruiters who found me due to the page rank of my website when I was doing a Google search for, I think it was web technical consultant or something like this. They managed to find me, and then they reached out to me via LinkedIn. And you know, it's only because I did other things that got my website the page rank it needed to be found that I'm at Google today, in fact. So I used to do lots of stuff for free. I did charitable work for various charities in England to make their websites, just to get more experience when I was younger, more junior person. And I often wrote blog articles for magazines whenever I could, just to get exposure. And these magazines and people would link, obviously, to my website as well to connect with me afterwards. And all of this gave me the page rank that Google ended up finding me. So it was a very interesting learning curve for me that networking is also very important in order for people to find you. And otherwise, I wouldn't be at Google right now. So that's very interesting.
Could you just explain what PageRank is for all of us?
Oh, sorry, yes. So essentially, PageRank is the algorithm that Google uses to rank the search results. So when you type anything into Google, you get the top 10 results. And it's, I can't explain the exact algorithm, and I'm not on that team anyway, but the general idea is that essentially, if reputable sites are linking to your site with certain keywords and links that are about certain subject areas, then your site also becomes related to those things, essentially. And that's how the recruiter found me, because I was talking about web engineering, security best practices, how to scale your website, and all these things that are related to web engineers and web consultancy. And essentially, my website became associated with web consultancy. And when people search for that, at least in England, people were then finding my results in the top 10, which is kind of cool.
So as you said, you prepared your website and that's how you got into Google. So was there any other preparation which you did to get into Google?
So I actually didn't do as much preparation as you might think. So because I was surprised by the Googler reaching out to me to work for them, I saw it as an opportunity to just practice my interview skills. I never thought I would be accepted at Google, honestly. I've worked with many intelligent folk over the years in my computer science degree and so on and so forth. And a lot of those guys and girls didn't actually get accepted when they actually applied. So I thought, well, at the very least, I'll treat this as a learning experience, and I can practice the interview at a Google level standard and just see the feedback that comes back. So I never assumed I would get further than the first few stages, but little by little, I kept getting to the next stage, and then it became more serious, of course. So as with anyone who's doing interviews, of course, you need to brush up on your knowledge of your algorithms and data structures and all this kind of stuff that you learn in your computer science degrees or whatever learning or background that you have. But just brushing up on those kinds of bits and pieces that are very commonly asked in interviews. But of course, I didn't know much about Google at that time and their process. I just did what I thought was best for a technical interview, essentially. And I just enjoyed geeking out with the person who was interviewing me and just talking about things that I was already passionate about. So I think at one point I was actually interviewing the interviewer because I was really interested about the subject area, and I was just asking them lots of questions. And we ended up having a good talk for over an hour on certain things. But it was good fun. I saw it as a learning experience and a fun way to talk to interesting people. And I think if you see it as that, you're much less nervous and you come across more confident as well. So, just treat it as fun and interesting, meeting like-minded folk, and that's a nice way to go about it.
That's great.
So
now
you have been in.
what?
Sorry. So has been in Google for almost about 10 years now, and he has
Yeah.
worked in 3 different teams. So how did you transition from a web engineer role to a senior developer at TensorFlow.js?
Yes, good question. So, so I started my career at Google as a web engineer, where I was making large, scalable web systems using Google Cloud, JavaScript, HTML5, all this kind of fun stuff. And this was more traditional engineering kind of role, more like a software engineer, except it was within the web space. And this was good, and I did this for about 5.5 years. But in those 5.5 years, I also did these things called 20% projects. And these are where you can take one day of your week to work on something that you're passionate about, essentially. And I soon realized that these things I was doing in my 20% time were actually getting a lot of interest internally and had good impact on other teams, but I didn't know existed at the beginning, but they did exist once I found them. And I ended up working with these teams in my 20% time to make very cool prototypes for their clients and so on and so forth. Now, what happened is they didn't have any headcount for me to join their team until, well, 5.5 years later. I actually met them like in my first year at Google, but until 5.5 years later, they didn't have the headcount to hire me. So we just kept in touch, and I kept hacking with them, making prototypes. And eventually I was invited to America to do a rotation, which is a 3-month full-time kind of deployment to a different team. And then the idea is after that, you go back to your previous team, which is more like a way to try something different for a little while and then go back to your team. However, the director in the new team invited me to stay in America, and I guess here I still am. I'm now based in San Francisco. So I guess one thing to note from that is that things don't happen instantaneously, and it can take a few years to find the right team that is aligned with your dream role. And I started my career as web engineering, and there's nothing wrong with that. I enjoyed web engineering, but the real passion for me came from starting with a blank canvas and innovating and creating things that had never been made before to make people go, oh, how did that guy pull that off, and get people's minds thinking and do creative experiences. And this is what I just started doing in my 20% time. And from that work, people noticed me, and then they invited me to join their team. Now, after I joined the team, which is known as the Zoo at Google, this was kind of like a creative agency inside of Google who deals with Google's top 100 customers around the world. I worked with them for a further 3 or 4 years, and essentially at that point I became very good at a wide range of technologies. So my web engineering role at Google made me super detailed and super pedantic about JavaScript and how to get every bit of performance out of it and how to write code in the most beautiful way. But then my creative engineering role, stroke prototype engineering role, allowed me to go wide. As I was talking about earlier, it allowed me to see the whole forest. And that allowed me to experiment with emerging technologies that I couldn't use in my first role. So I got to play with augmented reality, mixed reality, machine learning, projection mapping, all these exciting technologies that are very hot and trending at the time. I got to play with and experience, and that just gave me even more ideas of how I could combine them in different ways. And I don't know about anyone else on the call, but I watch a lot of sci-fi movies and things like this sometimes, and I often get a lot of inspiration from those. And once you know what is possible in all these areas, even if you're not an expert in there, you know what's possible at least. And then with a bit more tinkering, you can kind of poke things to work in a way that can be useful to you. And then you can combine it with a different area, and you've just created something completely new that's never been done before. And you can obviously then sell that through to a client or wherever it might be, or just try it for fun sometimes. But that's where I kind of started my creative engineering journey. And then finally, just in December last year, I joined the TensorFlow.js team at Google, which is basically a team that deals with machine learning in JavaScript. So just like the popular TensorFlow that's in Python, it's exactly the same, but in JavaScript. And this team is fairly new. It's just over 2 years old. And they got to the point where they're looking to now hire some more people. And the stars aligned that they wanted someone with a web engineering background who was also interested in machine learning. And if there's one technology that I really enjoyed using as a prototype engineer, it was machine learning, because almost all my prototypes ended up using that in some capacity to do what I needed to do, whether it was recognizing a customer's logo to trigger a creative experience or one of their products or whatever it might be. Machine learning was typically involved at some part of the pipeline. So at that point, I really loved ML and the web, and joining a team like TensorFlow.js made complete sense. And to be the developer advocate also made complete sense, because I really enjoyed like presenting and sharing my ideas and code and explaining things to the world. And as a developer advocate, it's your role to represent the team, the product team, to be the like an external face of that team, essentially. So I get to work with the developers around the world and put myself in their shoes and make sure that the developer experience is as good as it can be when you guys are getting started. Yeah, it's kind of a lot of cool things mixed into one role, and that was the right career progression for me, essentially.
Okay, so now that we have talked about your current role and the things that you've done, could we go to the demos now?
Sure, yeah, 1 second, let me present again. All right, so hopefully you can see my screen again. I'm just going to refresh the page here. Present.
Yes, sir, it's visible.
Can you see my screen? Yeah, okay, cool.
Yes, sir.
Awesome. So yeah, I want to show you a few demos, and these demos are using TensorFlow.js, which is the current team that I'm working on. And some of these are created in just one day, some of them are a couple of days. But I just want to show you how powerful it is, and what I mean by combining creativity with technical, essentially. Now, the first thing I want to show you is the ability to make myself invisible in JavaScript. Some of you may have seen this floating around Twitter fairly recently. And you can see on the right-hand side here, I'm in my bedroom, and I can get onto my bed, and I'm removed from the bottom video in real time using machine learning. And how I do this is using an image segmentation model that allows me to discover what pixels in an image are my body and what pixels are the background. And then I can learn what the background is over time and eventually remove myself completely. Now, the really cool thing about this is that it's not just replacing it with a static image. That's very easy to do. I could just snap a snapshot of my background, and then that would be it. But here, this is the important thing, is that I can get on the bed and you see the bed still deforming. So the background is actually updating. It's only me that is removed. And that's why it's much more powerful than just a static image replacement, which gives you this kind of cool Harry Potter ghostly effect, if you will. So that's the first example. And the other thing to note here is, because this is running in JavaScript in the web browser, your privacy is completely preserved. None of these images at any point are being sent to a third-party server for classification. All the classification, or inference, if you will, is happening on the front end in the browser. So that's really powerful. And it's also great when you've got a bad internet connection too, because the latency is all removed as well, because it's running all locally. To continue on that, I also made this Chrome extension that allowed me to run TensorFlow.js as a Chrome extension. And as you can see, that allows me to join Google Meet or Zoom meetings with these fancy effects. So you can see here where I'm segmenting my body, and I'm just highlighting what I'm finding for now, nothing too interesting. But you can see how someone comes in behind me halfway through the scene. But using the previous technology that I created, I could then use this to remove the second person and only keep myself. So then if someone comes into your room midway through a video call, you can then have the assurance that they're not going to video bomb your call. And if you've got children or something like this, you can be sure you're not going to be interrupted on some important business call or something like this. So lots of ideas come from previous ideas you've created, and you end up with this chain reaction of interesting things you can create. And to go further, like here's another problem. Sometimes ideas come from problems you have in the real world, of course. And here's an example I use, again, using the same image segmentation technique as before, where I can estimate my clothing size in real time in the web browser. Now, I don't know about any of you on the call right now, but I'm terrible at knowing what clothing size I am. Every single brand seems to have different measurement scales and things to how to define what a small, medium, or large t-shirt is. So with this technology, I can measure myself in real time in the web browser in under 15 seconds, and then it can automatically highlight and tell me what size clothing I should buy from that particular site. So once again, the same model used in like 3 different ways, and all quite useful potential purposes too. But we can go further. If you take it one step further, if you add WebRTC, which is our ability to communicate over distance using JavaScript, we can actually teleport ourselves too. So here you can see myself taking myself from my bedroom, segmenting my body in step 2, and then transporting myself to a whole different room, which could be anywhere in the world, in order to then talk to someone remotely. And if you try this, I haven't released it yet, but hopefully one day when the code is public, if you ever try this, you'll be able to actually feel like you're really there with that person, especially in the current times where everyone's stuck at home and it's hard to go out and meet people. This gives a more immersive experience rather than being stuck in a little video rectangle on your screen, which is very impersonal. I can walk up to myself in this, and I can go and inspect myself and look around myself and kind of like have an interaction, you know. And of course, you could have much more advanced effects with a bit of time and thought as well. So yeah, that's all from me for now. But if you want, I can talk about what the community has been making too, if you're interested, or up to you. Let me know.
So I just wanted to know about the technologies that you used. So could you just tell us about WebRTC?
Let's go back to the beginning. Yes, sure.
Yeah. Okay. So what exactly is BodyPix? Is it the name of the body segmentation model?
Correct. So yes, BodyPix is one of the models that TensorFlow.js team has produced. These are all open source on our GitHub repository. We'll give some links later in the presentation. But essentially, yes, this is one of the models that make it super easy to use machine learning. And this model simply takes an image as an input, so one frame of the webcam image, for example, and then it'll give you a JSON object returned that contains the information of what it thinks is in the image. So it'll classify each pixel in the image as body or not body. It's like a binary mask, if you will. And you can then use that information to then do what you wish. And in my case, well, most people will probably use it to like highlight the body, but of course, me being me, I decided to remove the body instead and use it in a non-conventional way. And that's the other point. Try and think outside the box and try and use these models in ways others haven't tried before. Don't just copy people, but really try and push things to the boundaries of how you can use it. If you can see where something is, you can also see where something is not. And it's good to kind of think of the opposite way around sometimes too, to make things like this. And all of these demos here, right here, this Chrome extension and this image segmentation model and this teleportation all use the BodyPix model to segment me, as you can see in step 2. And the only difference with the last one is that I'm combining it with other emerging web technologies, such as WebRTC for real-time communication, which allows me to transmit that image frame over the internet to a different device. And A-frame or WebXR is allowing me to do the mixed reality, which allows me to place that image at a certain position in the real world, just like augmented reality and all this kind of stuff that you might be used to. Same kind of technology as that, but all in JavaScript without having to install any other applications. And then 3.js allows me to do things in 3D, obviously, and all that good stuff. So often if you take one technology and combine it with others, you can get some really powerful things. And the same goes for machine learning with TensorFlow.js as well.
So, sir, how do you get these creative ideas? What makes you do all these creative things and not the
So
normal things?
that's a very interesting question, actually. It's a mixture of things. So the example you're seeing right now on the screen actually came to me when I was dreaming one night. I tend to have technical dreams where I am coding in my sleep, literally. I have Sublime Editor open in my dreams, and I can actually code, and I get an idea for the algorithm that I'm trying to do. And obviously, dreams being dreams are not perfect, but I had an idea of how I wanted to solve the problem. And I thought, oh, maybe I should actually try this out. And this started very simple, just by segmenting my body and making the invisibility demo that you saw here. But then that evolved into this teleportation demo by adding more technologies to it. So often I'll start with something more simple, like the invisibility one, and then evolve it over time as ideas build upon ideas to end with other prototypes too. Now, the other way to go about things that I find quite useful is to find a problem in your life and try and solve it. So here, for the clothing size estimation, as I said, I'm terrible at buying clothes. And I was thinking, well, there must be a better way to make this more frictionless, essentially. And of course, I was playing with body pics for a while, and I figured, well, if I know my body is, surely if I give it my height, I can then figure out how many pixels are representative of that height, and then I've got a ratio I can use to measure any part of the body. So then all I needed to do was figure out where the key parts of my body were, which actually was a little bit tricky. But once again, this demonstration was made in just 2 days on one weekend, and it was really fast to put together because I was using this pre-made TensorFlow.js model. So all of that kind of complexity is abstracted away for the machine learning. It makes it super easy to use and get these superpowers for free. Yeah.
So you talked about making things less complicated. So could we go to Teachable machine now?
Sure. 1 second. Let me load it up on my browser, and then I'll switch tabs. 1 moment.
Yeah, no issues.
Service tab. Cool. So yes. Now, some of you, I remember talking to you at the beginning of this talk whilst we were waiting for it to kick off. What's your experience in machine learning? And there's a lot of people who are completely new. There's a few with some basic experience, and 1 or 2 who are experts maybe. And the thing is, you don't need to be an expert anymore to take your first steps. And this just 3 or 4 years ago was not the case. You really had to learn a lot of stuff to do machine learning. But with Teachable Machine, this is a web page that has been built by Google. And you can see here, there's 3 types of machine learning you can do very easily with no machine learning experience and even no programming experience. We can recognize objects from an image, we can recognize sounds, and we can recognize poses. So if I go to image here, you're then presented with this interface, as you can see. Pardon me. So if you go to class 1 and click on webcam, we get a live preview of me. So I'm just going to click on this blue button, hold to record, and just take a few samples of my face. So I've got 43 image samples here. So I'm going to call this class Jason. There we go. And now I'm going to go to class 2, and I've got a deck of cards in my room. So I'm going to do the same thing with this deck of cards, if I can find them. Where are they? Oh, here we go. So now I'm going to hold this nice deck of cards up to the screen, and I'm going to take a similar number of samples of that too. And now all I need to do is click on Train Model, and in real time, just in the web browser, remember, none of this imagery is going to a server to be trained or classified. In my web browser, this is now going to retrain the top layers of the existing machine learning model to adapt it to recognize the things I just showed it, essentially. And you can see here's the live preview come back. In just 30 seconds or so, it's done. And now on the right-hand side here, you can see at the bottom, it's predicting Jason. And if I hold up these deck of cards, it says cards. So Jason, cards, Jason, cards. And you can see how responsive that is. And in just 2 minutes, anyone on this call can go to this website, teachablemachine.withgoogle.com, and they can recognize anything in their bedroom as well. So you don't need to be an expert to take your first steps and realize how fun this can be. And this is when you start learning about how deep the rabbit hole goes, of course. And if you want to make these things completely from scratch, you have to do a lot of learning, but often you don't need to. And I encourage everyone, no matter what their background, to just try this out after the call and just learn how to recognize things and also learn the limitations of something like this. I've only used 43 images for each class here. And whilst that works very nice right now in this demo, if I showed it my mobile phone, it might call it a deck of cards because it's also rectangular or something. So you would have to add more imagery to make it more robust so it doesn't have bias towards one thing or the other, essentially, okay? And of course, that needs more training data and more time and more effort and maybe even more perfectionist machine learning models that might be custom to the job as well. But for simple prototypes, I've had people use Teachable Machine for combining it with things like Raspberry Pi, so they can control their garage doors. If they've left the garage door open or closed and it's nighttime outside, they can check if the garage door is open just by.
How do people make their projects and make their projects visible to people and to you? And how do you recognize these projects and how do you show it in your show and tell?
Sure. So let me just stop the slides for a second so I can be seen. There we go. So yeah, basically, there is a hashtag made with TFJS, as you can see on my bag behind me here, nicely advertised. And this is something that our community uses. If anyone's using TensorFlow.js to make a cool prototype or a cool innovation, you can use that on Twitter or LinkedIn. And me and the team will search this every once in a while to see what's being created. And if there's anything that's particularly cool or exciting that we haven't seen before, we invite people to our show and tells, or maybe once all this coronavirus stuff is finished, maybe an actual event or something like this in the future, where we ask them to explain, like, you know, how did you make it? What did you learn? Tell the community about it. And they get some time to talk about this with me on the show and tell in this current case. So yes, please do share with me what you make if you are interested, and I'd love to see what everyone is creating, definitely.
Okay, so now we talked about all these cool projects and things. So now we could just go into some tips on how people could start with AI in general.
Yeah, 1 second. Let me go back to the slides. Just before I get started though, I would like to just show you some of the things the community have already made as we were just talking about them. So just in case you're interested here. So you've seen a few demos that I've created, but what is everyone else creating? And these people are from very varied backgrounds. Some are very new to machine learning, others have a little bit of experience, and some are new to JavaScript and machine learning at the same time. So if these people can do it, you know, everyone can. So here you can see how someone's combined. Can you see my screen okay? Yes, you can. Yeah, he's combined TensorFlow.js with WebGL shaders to turn himself into like Iron Man, essentially, and he can shoot these like lasers or rays from his eyes and mouth in a really smooth way, like 60 frames per second, I think, on his website here. And this guy had never used TensorFlow.js before. He just saw our face mesh model that allows you to understand the key points on your face, so he could identify where the eyes were and where the mouth was. And using that information, he could then combine that with his knowledge of 3D to make this very cool effect. And of course, here's a guy from Paris in France who took it to a whole new level as well, where he can scan a magazine, and if there's a person in that magazine, he can extract that person using the same model that I used, body pics, and then he can bring them into the room, so he can actually then walk up to the person from the magazine and kind of inspect them in more detail, which is really interesting, especially for like fashion or something like this. And of course, he combined it with some really cool particle effects using WebGL and 3.js, for example. So my question here is that, you know, what will you make? And here's one more example from a guy in Tokyo in Japan. And this guy has a background in dancing, actually. He's a dancer. And this just goes to prove that even he can use it to create these really cool hip hop videos with this interesting effect. So machine learning now really is for everyone. And I'm super excited to see how people will start using this in creative ways beyond just the pure academic, and how musicians, artists, creatives will start using this technology too. And I think once they start embracing it, we'll see very interesting use cases come up that we haven't even dreamed up yet. And I think TensorFlow.js can be one of those technologies that enables people to start using this at scale, which is kind of cool.
So now that you're talking about making things easier and making accessibility for people better, so now could you guide people into if they wanted to get into AI, how could they do it?
Yeah, totally. So as I mentioned, there's a whole bunch of machine learning models that our team has produced already that are open source and free to use and try. I'm just going to show you a couple of them right now, in fact. So in addition to things like body pics, we've also got like object recognition, which you can see here, which gives you the bounding box of 90 common objects you might want to recognize: dogs, cats, humans, mobile phones, this kind of stuff. And you can see here, you get this nice bounding box coming out on the right-hand side. And if I click on this demo, fingers crossed it works. Let me share this tab. Let me just let this load for a second. My internet's a little bit slow today, especially whilst live streaming to everybody at the same time. But once the model loads, this code is actually available for you to use on Glitch or CodePen. So you can actually go to these sites and take my boilerplate code for these machine learning models and use them in your own projects and transform them into something else. So once you can recognize a thing, what are you going to do? Of course, it's up to you, but you can see here, I can click on any of these images on this web page, and now I can classify them in real time. And you can see it can even classify multiple objects on the right-hand side here, 2 humans and a dog, and it still manages to pick them up. And if I enable my webcam, you can, of course, do this live on your webcam as well in real time, and you can see it recognizes me as a person with 96% confidence, which is very reassuring that I'm looking like a person today. So that's the object recognition example. And if I go back to the slides, 1 second. We've also got face mesh, and face mesh is just 3 megabytes in size, but it can recognize 468 facial landmarks, as you can see in the animation on the left-hand side. And with this information, it's endless possibilities what you can make up. And you can see on the right-hand side here, Modiface, which is part of the L'Oreal group, have used face mesh to do virtual AR makeup try-on. So the lady on the right-hand side here is not actually wearing any lipstick at all. And she is actually using TensorFlow.js to try on virtual lipsticks using WebGL shaders and all this fun stuff to make it look realistic, of course. So this is a really cool one that I want to demo as well, just whilst we're here in the show. So if I switch tabs, hopefully you can now see me with a face mesh, and it's pretty performant. I'm getting 25-ish frames per second whilst I'm live streaming as well. Usually I get more like 35. But note that this is actually running on the processor of my computer. At the top right here, I can actually switch to WebGL, which means it would run on the graphics card and be even faster, which is kind of cool. And because this is in JavaScript, not only are we doing the machine learning on the left-hand side, but we're rendering in 3D my face as well on the right-hand side, which just shows you JavaScript has been designed from day one to be interactive and to display information and graphics and so on and so forth. And it's a very rich language for this kind of content especially, and I encourage people to explore these very mature libraries for graphics and stuff too. So if I go back to the slides, 1 second, let me just see what was next on here. And of course, that's the body segmentation model I was using for the various demos before. Here you can see how the segmentation comes back, but it also gives you this pose estimation, these lines inside of the bodies on the right-hand side, which gives you an estimation where the skeleton of your body is. And with that, you could maybe recognize a gesture or something like this with further training. So there's lots of potential here, not just the segmentation of the body, but pose and other things too. We spoke about Teachable Machine, of course, and Teachable Machine is great for prototyping, as I mentioned, for something in your bedroom or something that's just going to work with you and your friends or something like this. But if you want a much more scalable production level system, then I recommend something like Cloud AutoML, which you can see here. And with this, you can actually export to TensorFlow.js if you so desire, so you can use it on your website. But this allows you to have much more training data, maybe gigabytes, as you can see here. People have uploaded loads of flowers of different types. Maybe there's 1,000 images for each one. And you can then use those to train a very nice custom model. As you can see here, you can choose to have higher accuracy or faster predictions. You can choose the trade-off that you want as the creator of this. And then a few hours later, Google will give you a little page like this, and you can click on export to TensorFlow.js, and that will give you a JSON file you can then host on your website and use very simply. In fact, it's so simple, you can actually do it in just 3 lines of code. You can get that code working on your site if you wanted to.
That's amazing. So I am a full stack web developer, and I plan to get into AI maybe next year or so. So,
Sure.
so what would you recommend to me as a web developer to get into AI? How should I
Definitely.
go about it?
So I'd recommend maybe taking a top-down approach. So start off just experimenting with things like Teachable Machine, Cloud AutoML, get a feel for how you're producing these models and what the limitations are too, and how you might want to think about perfecting those. Maybe you need more training data, maybe you need a better model, so on and so forth, and just get a feel for it first of all. Once you have more confidence in just loading training data and training models using these graphical interfaces, then you can start looking into maybe taking your first steps in coding things yourself in something like TensorFlow.js. And you can then make your own model architectures or use an existing one, or use transfer learning, which is where you take an existing architecture and its data and then use what it's already learned to then learn something else, which is similar to that domain problem. So there's many different aspects you can take without having to go the whole way, so to speak. In fact, 99% of people won't need to make their own machine learning model from scratch. There's probably one that exists that works very well for your use case. You just need to retrain it on the data that you have rather than the one it was trained on. So that's something to think about. Of course, there's a great book actually for that. I've got it on my desk here. Deep Learning with JavaScript. This is by Manning Productions, and it's actually written by folk on the TensorFlow.js team and TensorFlow itself. Is a kind of combined effort, and it has everything. If you're completely new to machine learning, as long as you know some basic JavaScript, it will take you from 0 to hero, and it covers things from very simple things like linear regressions to the very experimental things like generative networks that allow you to generate imagery and all this kind of fun stuff. So it's a good 10 chapters or so in there. It's a nice thick book, but it's written really well. And I'm actually halfway through it myself, as I only joined the team 6 months ago myself. So I'm still learning a lot of things too. And it's been really good so far. So I highly recommend that if you have any kind of JavaScript knowledge. And if you're new to JavaScript, maybe you're in Python land already, it's also a good way to get the understanding of what the difference is between Python and TensorFlow.js and that kind of stuff too. So definitely worth it.
So basically, is that I should go from experimenting with ready-made models and things like that and include them in my applications, and then once I know the limitations and the way they work, then I should go into the deeper stuff, into the maths of it and into the models and reading things myself.
I think that's a nice way to start, especially if you're not experienced in machine learning. Obviously, if you're already a pro, you might have some lower level things you can use or reuse already. But if you're new to it, you start higher up and then start to unravel the onion, so to speak. And as you go deeper, some things might make you cry because the rabbit hole is very, very deep. But you can unravel that as you need to and take each step little by little. And only need to go deep on the areas that you really need to perfect, essentially. And that makes it more manageable to understand. If you try and tackle the whole of machine learning in one go, it's too vast of a subject area to complete in one sitting. You need to just see the forest first and then choose a tree to start climbing. Yeah.
So I am a person who likes to do a lot of things together at one time. So just like you, how you like to do hybrid engineering, that mixture of a lot of technology. So would you suggest someone to specialize in one particular field, or would you like someone to have a mixed base like you have?
Sure. So you can actually see from my career history at the beginning of his talk, I started by specializing, in fact. And I think, if you rewind your whole life to when you were a baby or something, you're freshly born, you had to pick something to specialize in, whether it was walking or talking or something. You had to pick something to get good at that initially. And in the case of this kind of stuff, programming is that thing you should specialize in first, of course. Learn how to be a very good programmer. Learn how to write maintainable code, scalable code that is secure and not going to get hacked, and all this kind of stuff. Make sure you really understand the language of your choice, whatever that might be, JavaScript, Python, whatever it is that you choose to use. Now, once you have gone deep in that, then I would recommend going wider again to see, okay, I'm good at programming, but what are all the different areas I can play in now that I know how to code? And there's thousands of different areas. There's smart devices, Internet of Things, machine learning, augmented reality, robotics. I could just go on for days listing off really cool subject areas that you might want to play with. And it's at that point you should then kind of learn a few of these. Don't have to go deep in all of them, but learn maybe 2 or 3 of them. And that's when it gets powerful, because at that point, not only can you, let's say you specialize on the web stack, then you know how to do all the web engineering to make a prototype, but you also know how to combine that with unique technologies. And very few people know how to combine industries together. So if you are interested in music, then maybe you want to combine your love for music with JavaScript programming and do something uniting those two. And you'll find that there's a lot of interesting APIs in JavaScript for multimedia that will make your life easy. And of course, you already know about music because that's your hobby. So if you combine the two, that's kind of unique. And also then you are standing out for your CV on LinkedIn and stuff, because instead of being a generic, I'm passionate about machine learning, which if I had $1 for every time I saw someone adding me with that on their title, I'd be a very rich person. But basically, instead you can be, I'm passionate about machine learning for music creation. And that is when you have a real unique selling point versus everyone else you're trying to compete against. And that can give you an edge when trying to look for a job. And of course, you're more likely to find a job that is interesting to you because you love music and stuff. So, so pick a couple of industries that you want to be curious about, go deep in those, but also just be aware what else exists so you can cherry pick little bits from them to bring it into your industry as well. Yeah.
So that's a very nice thing. And you talked about jobs and LinkedIn. So I would just like you to tell us about the importance of networking for somebody.
Yes. And this is like something you realize as you get older in life, honestly. And I'm certainly not like the oldest person in the world, but even at my current age, in my 30s, the importance of networking is worth more sometimes than your education in places. Now, of course, I did a degree, I got good marks, I studied hard and all this stuff too. And you still need that to pass your interviews, of course. But sometimes you might not even get an interview if you don't know the person who's hiring and this kind of stuff. That might be the introduction you need for people to be like, okay, yeah, I want to interview you in the first place because they know you exist. And a lot of students I've spoken to in my various past often forget that they need to kind of keep these connections and their network growing to find these opportunities. Things will not find you by chance. It's more that you have to put the work in so people know you exist. And in my case for Google, Google only knew I existed because I wrote for blogs in my spare time. This was not paid work. This was me just doing it because I enjoyed writing about the tech stuff that I was nerding out on. And these blogs link back to my site and so on and so forth. I did charitable work for sites. I didn't get paid for those at all. These were just things I did out of the goodness of my heart, so to speak. But the knock-on effect was that when people asked those people, who did your website? It's like, oh, it was this guy. And word of mouth goes a long way sometimes too, especially if these things are kind of high-profile situations. So yeah, good can come from just being good. So it's like a positive spiral effect, which is great. Yeah.
So you talked about your portfolio and stuff. So what would you advise people? When should they start building their LinkedIn profile and their portfolio and their personal portfolio website or something?
Yeah. The personal portfolio, like if you're serious about programming, you should already have one. If not, get on it. Make sure you have your CodePen examples, your GitHub examples, things that show like the coding standard you're working to. And they often, like, especially if you don't have a computer science degree, you should look at the coding standards companies use. So Google, for example, has the Google Code Styling Guide that you can just search this on Google for the language of your choice, JavaScript, C, Python, and you'll find this like XML file with all these details of how Google engineers write their code. And if you can already show you can write your code to this level, that is good. It shows you can write consistently and to a good standard, and it's reusable and has certain implications essentially. So once you have learned to program, make sure you can program so that others can understand what you've written. And these coding style guides are very important for that kind of stuff. So when you're publishing your code to LinkedIn and GitHub, in addition to the documentation being decent so people can understand what you've created, make sure the code is readable and formatted perfectly, and put your best foot forward basically when you're presenting your work and polish it up. Yeah.
So, sir, from your experience in tech industry and in life in general, what would you advise people to be successful like you? And also, what was your mindset like when you just started with ML and AI?
I don't think there's like an official formula, but the things that I've noticed have helped me over the years is that I've always just been curious, and I encourage people to explore their curiosities. Too often people have an idea and they think about it for a little while and then they don't act upon it. And the hardest thing to do is to start a project. Once you start it, it's kind of like things are moving, the momentum is there, but the hardest thing is to start it. And I encourage people just to force themselves to start putting an hour aside at the end of the day after your job and do that thing you had an idea for. And more often than not, especially if it's solving a problem, like my clothing size estimator, for example, other people have the same problem, and people start talking about it, and people start referencing it, and it grows by itself organically. You don't need to have advertising or any of this. You don't need to pay for anything. Just make good stuff that solves problems in the world, and people will find it useful, and people will naturally start blogging about it and talking about it all by themselves. So yeah, stay curious and explore things, and be proactive in that sense of forcing yourself to do things. Don't wait for someone to tell you to do it. Just go and do it. Yeah.
So you talked about when we were talking before a few days ago. So you told me about your invisible demo. I'm sorry.
Yes.
You told me that you made it in a day, but you had a lot of hours of frustration. So you also told me about the importance of
Yes.
perseverance over there.
Yes, and I think a lot of people never see this side of the end result. That when people see the demos that I create, they're like, "Oh, that's really cool," and they don't see the many hours where I was shouting at my computer screen or all this kind of stuff when I was stuck on something. And I was, I did it in a day, but I was working pretty much solidly the whole day. And I think I skipped my lunch because I was so involved in the programming, I've forgotten to eat that day as well. So I'm not recommending that, of course. Please do eat. But sometimes when you're really into a problem, you can forget about these things. And I think it's important to, yeah, kind of. What was the question again? Sorry, I got off track slightly there.
I think he wanted to know what was your mindset like. Why didn't you give up?
Oh, yes,
If you were
yes,
frustrated.
yes. So yes, you will bump into problems along the way, and the important thing is to have that perseverance to stick through it. So I could have given up. As soon as I hit the problem, I could have, okay, this isn't working, and I'm done. And then the invisibility demo would never have existed. A few more hours of work was all it needed for me to figure out the solution to that problem. And it can take time sometimes. This is an ideal situation. Sometimes I've worked on projects where it takes me weeks before I get the answer. And especially on more production level things, which are much larger scale projects, maybe even years. So you've got to just have it, put it on the back burner, go back to it after a few hours if you need to have a break or something, but go back to it is the key thing, and have another stab at it with a fresh mind sometimes, and keep chiseling away little by little, even if you might find that the technology doesn't exist to do what you want. Maybe I want to do the invisibility demo, but it works at 1 frame per second, let's pretend. So maybe I just need to wait for hardware to catch up or something like this. But that's a different problem I can then look into and wait for that to be solved, and then combine that technology with.
So you told us that this idea came from a sci-fi movie of making
Yes,
yourself
I do
invisible.
like a lot of sci-fi movies. I'm a big fan of Star Trek and all these kinds of things. Yeah.
So my question is, so if I'm getting an idea which is very unique, but I don't have the skills to make the idea possible or reality, so what should be my next step? So should I approach people, or what if people take away my idea and name them as yours?
Sure. So if you don't have the skills, there's a number of things you can do. So at Google, there's actually a process called design sprinting. This is not the same as a product sprint for coding. This actually involves no coding at all. And there's many books on design sprinting, but essentially it's in 1 week, you put together a prototype, and by prototype, it could just be Adobe Photoshop mock-ups of the UI doing things that doesn't actually do anything, but it shows the user what would happen if it worked. And you can get a lot of feedback from users, UX studies, to see if there's interest and all that kind of stuff. Now, if that shows promise, then of course you need to figure out what skills you don't know. And this is actually a very good skill to have, is to know what you don't know. And I guarantee that once people graduate from degrees, myself included, back then many years ago, I thought, okay, I've mastered computer science. I know all I need to know forevermore. And of course, that was very naive. And I soon realized there's things like security and scaling and all this other stuff that I didn't know fully, and you learn this sometimes on the job, and sometimes because something happens and you have to suddenly fix it, right? So yeah, I encourage people to keep learning in that sense, of course, in order to make that happen.
One more question.
One more time, sorry.
What?
Can Anushka just repeat the question one more time? I just want to make sure I covered it fully.
Okay.
Yeah. So my question was, what if I am getting an idea of something
Oh,
very
yes, and the
big,
privacy
but
side
I
as
don't have the
well.
skills?
So, yes, yes. So if you don't have the skills, of course, then how do you go about finding people to help you make that thing? Now, of course, this does involve trust. And with any good startup, the first 20 people or so are critical that you trust them completely. And you can use things like NDAs, non-disclosure agreements, to kind of, when you're discussing ideas with people before they've actually joined you, it's a legal binding agreement that if they talk about it, then, well, you can sue them or something like this. So, but it's not a patent either, and you can't patent an idea. So you're in this kind of gray area where technically, yes, they kind of promise that with an NDA that they're not going to do anything, but a really determined person could, like machine learning in general. Like TensorFlow.js is just a machine learning library, just like TensorFlow. So in that case, it's like, what can machine learning do for businesses? And that, it depends on the business you're in. It depends on so many things. But I'd encourage people to think about what things they're currently doing that could utilize machine learning to make that more efficient or more accurate or more cost effective, all these kinds of things, right? And certain industries might be easier to do than others. Like obviously doing anything in healthcare, the barrier for getting something wrong in healthcare is much higher than, say, if I just want to classify if my garage door is open or not. So certain industries will probably adopt it faster than others. But I'd encourage you just to look at your day-to-day situations that you have data for, and hopefully, if you're not recording data, start recording data for various things that matter to your business, and then see if you can use a machine learning model to take that data and predict the thing you're already doing. And with that, you might find some low-hanging fruit that could work well for your business. And of course, remember to record how efficient the current process is. If it takes you 5 minutes to use a human to do that thing right now, and it takes 10 minutes for the machine learning model to work, then obviously that doesn't make sense to use machine learning, right? So be sensible and make the recordings of the performance as required as well. Yeah.
So someone asked, what is the role of deep fakes in the society?
What is the role of that? I mean, they can be used for many different things. We've like people from our community have used it for very creative purposes, where they can like wear face masks and things like this and all that kind of thing. Or you can turn yourself into a cartoon character and this kind of thing. So there's lots of interesting potential here. And we've seen it used for generative artwork. People have used it in the artistic community to make paintings and things like this that are very abstract but very interesting, based on the same technology, the generative networks that exist in machine learning. So as with any tool, it can be used for good and bad. Hopefully more good comes from it than bad, of course. But yeah, I encourage people to use it for creative, artistic purposes rather than anything bad.
Okay, so now we have finished our questions and some of the questions that we've taken from the participants when they're registered. So now we would like to call upon Ananya Arora, our guest speaker winner. So if she's online right now, she could ask her question. Just give us a minute.
Sure.
Yeah, she is online. Go and ask a question, Ananya.
Hey there.
Hi, Mr. Jason. I'm Ananya, and
Nice
I
to meet
just
you.
want to tell you that I had such a great time listening to you. All your applications that you've made, the prototypes, everything, demos was so interesting, and I'm definitely going to try them soon. And I just want to
Excellent.
thank all the ideators who's given me this opportunity to ask you a few questions. Okay.
Wonderful. Please do. Yes.
So, like all the technical questions have actually been covered. So, I just want to talk a little bit about your journey.
Yes.
So, how has a failure, made a positive difference in your life? So, could you just tell me a little bit about a failure that you went through and how did it make a positive impact?
Sure. It's a great question, and as I kind of hinted at in previous discussion, like there's often moments when you're working on something where things don't go as expected, of course. And I think the key thing here is that you approach it with a positive attitude and see it as a learning experience. For every failure, there's a learning to understand why it failed and what can be improved in the future so it doesn't fail in the future again. And as long as you have that learning, then that failure can be turned into a positive. If you fail without learning, then you're going to fail again in the future. So I always try and analyze what happened and try and learn from it, essentially. And this has happened numerous times in various projects I've worked on. where I've got a vision for some new idea that I have, and I think it's going to be easy to reach that end goal, and something doesn't work as expected, or some technology gets deprecated, or whatever it might be. There's always something that crops up. Nothing is ever smooth sailing in anything that I've created. There's always things that crop up from time to time, and the key thing is to kind of adapt and learn and move forwards always.
Okay, that's nice. So in the first slide, you kind of showed your whole journey from where you started and where you are now.
Yes.
So would you change anything about that, or do you regret any part of it?
If I change anything, I wouldn't be where I am right now. So I guess it is what it is. I don't regret anything. I thoroughly enjoyed my time working in startups, and I highly encourage people to explore startups when they're younger as well, because you've got less commitments, and both financially and family related as well. And as you get older, these things become more top of mind, and that's when working for a larger company is nicer, because you've got more stable income and so on and so forth too. But with a startup, you learn a lot, because the people who hire you at the startup are literally depending on you to make it a success. And if you mess up in a startup, the consequences are real. So you learn a lot very fast, but the same, I guess the same things you learn in that environment can be applied to large companies too, to make you even more successful at those large companies, in fact, because if you think like a startup when you're at a large company, you actually end up performing using much less resource and so on, which of course they appreciate, because you're not wasting money, and that leads to better performance results and all this kind of stuff. So all of these things can go on to give you good learnings at the larger companies too. And maybe your startup becomes one of those unicorns that actually is very successful. So there's always that chance as well too. So I'm very happy that I started with startups and then went to large company, versus starting at large and then going to startup, because I would just assume if I'd started at Google, oh, there's going to be free meals and there's a backup plan always, and there's education for free and all this kind of stuff. So that just doesn't happen in startups. So it's good to have that experience first and then get used to the larger company life after that.
Yes. So can you just advise all of the students, how do we find our calling? How do we know that this is what we want to get into, this is what we want to eventually end up
that's
doing?
a great question. So I guess my short and sweet answer here is, if it feels like work, it's not what you want to be doing. And all of the demos you saw today, I created on the weekend. Even though it's kind of my job to make these things, I actually did it in my spare time, because it didn't feel like work to me. I would have naturally made these things anyway, even if I wasn't in this role right now. But do what you enjoy, and then try and find something that allows you to do that full time. And as you heard at the beginning, it took me 5.5 years after starting at Google to find the team that allowed me to do what I was doing in my 20% time, 100% of the time. And sometimes it takes perseverance to stick through that until you find the headcount or the team that you need. Some of these teams are very hidden, and for good reason, obviously, because if everyone could just make cool things every day, then Google wouldn't have any software engineers to do the actual implementations for the larger products. So these teams are sometimes harder to find, but they do exist. And if you're willing to persevere and show that you're a good programmer and all these other things, and then show that you're also good at the creative side, or whatever it might be that you're interested in, find the companies that do those things and then apply to those. And hopefully, if you show that you're that unique cross of skill sets as well, that can work out really nice. As I said, the music and engineering example, that will make you stand out much more than a generic software engineer, which there are millions of in the world. Everyone from computer science is a valid software engineer, but not every computer scientist is a valid software engineer with expertise in music programming and all this kind of stuff. So whatever it is your passion is, combine it with that and find a job that does that.
And okay, what is one piece of advice, a conventional piece of advice, that you disagree with?
Oh my.
Do you have any?
I'm not sure if I listen to many things. Actually, I tend to just make up my own rules, honestly. I kind of ask for forgiveness later when I've broken something. So yeah, I guess I'm more of a tinkering hacker kind of mentality versus following any approach out there. I guess the one kind of thing that I just invented myself, which is actually on my personal website as well, is a little phrase I came up with, is no, as in KNOW, no limits, and no limits. And I always try and assume everything's possible until I prove to myself it's not. Because if you assume it's not possible, which a lot of people often, I've had ideas in the past where people will shoot me down and be like, oh, but you can't do that. And then a year later, I make the thing, and it's like, so don't always listen to people who say it can't be done. There's a lot of people like that, and just stay positive. It might not be able to be done now, but if you just keep at it, maybe with a little bit of hard work, you will get to that point where you make the breakthrough. And sometimes, as you saw, it's just a few hours difference for the invisibility demo between that being created and me just giving up on that and never doing it again. So stick at it. And if you don't get somewhere fast, then of course, just put it on the side, but come back to it in like 3 months or a month later or something and try again then when things may have changed. So you don't have to do it all the time. Like don't burn yourself out on that one thing, have variety, but yeah, just keep it on the back burner as something you can revisit in the future. Yeah.
And I wanted to ask you, like, how do you think technology is going to prevent, another health crisis in the future? Like, what do you think about this?
That's very interesting. Obviously, with the current times, there's a lot of people working from home remotely and social distancing and all this kind of stuff. And I think one thing I've learned from this experience is that the tech community especially has come together in producing tools and things to make your remote work much more productive, more fun. Things like my teleportation demo, I can actually kind of be there without being there. It's kind of nice, and have a more personal experience. And it does feel better than a video call, but still doesn't replace, of course, real human contact. But in these harder times, it's a nice compromise at least. And I think we'll see more stuff like that coming out in the future. And I'm very interested to see where that creative side goes. And of course, as people get more creative, who knows what might be made, in fact. So, yeah.
Yeah, and I also wanted to ask you is that, okay, so because of this COVID-19 situation, I might, end up taking a gap year. So
Sure.
in my gap year, what should I focus on to, improve my chances of being hired by like the big 5 or like the good companies? So what should I focus on, like projects or more of courses, or, what should I do?
So what's your background? Do you have degree or something, or?
Yes, I'm doing electronics engineering, but I'm kind of shift transferring to computer science, like for my master's.
Okay. Yeah.
So yeah.
So yeah, I mean, you've already got a degree. So I mean, that's like for many, degrees aren't even needed at companies like Google, honestly. So it's more about showing that you're capable of doing the job you're applying for, and that you stand out against the other people who are applying for that job. That's kind of the gist of any situation, whatever you're going to interview, not just Google or anywhere, but everywhere else too. So I personally would focus on building up your portfolio and make sure you've got good examples that do like things that make the recruiter go like, wow, that's actually pretty amazing, and like we should definitely get this person in to be at least interviewed. And then of course it's down to you to brush up on your computer science skills again to remember all that stuff from the year before. But yeah, definitely just be creative. Use this gap year to be creative and follow the things that you don't consider work, as I said, but combine it with your knowledge of electronic engineering and computer science to see if you can make something that combines your passions with that. And if you do, you might just become known for it. And at the very worst case, you got something that's good for your portfolio, that was fun for you to make and you were excited about. And in the best case, it leads to someone who would just happen to be looking for someone to do that kind of combination of skills that actually may find you because you made that thing, and they ask you to then join them as well. So yeah, and don't just do one thing, but try and do like one per week and then one per month. Have some short-term and long-term projects as well. Have a variety there. So then by the end of the year, you've got like 10 or 12 pieces of really good work that you're proud of. And maybe you write them up on blog posts, talk about them in the community. If you use TensorFlow.js, use the hashtag, and hopefully I can see you in the future then in our show and tells. And yeah, just make stuff. And gap year is a very rare chance to do that kind of thing. I actually had a gap year before I went to university too, but for me, I didn't have the luxury of using it to learn. I had to work, actually. My first job, which was not really on my LinkedIn, I actually worked at my high school as their network engineer. I got invited to become their network engineer. And that was my first ever job because I needed the money to pay for my university degree. I didn't come from a rich family or anything like this. So I had to spend a year working. That became, I guess, my own little portfolio. I managed to do this work experience thing that lasted a year, that was managing all these computers and things like this. That actually gave me an edge then for other things. So yeah, use it productively, I guess, and creatively would be, yeah.
Oh, I just have one last question. I'm sorry,
Sure.
I'm really excited.
That's okay.
So if you could just give your 20-year-old self one piece of advice, what would it be?
I think I'm going to go with stay curious and persevere with things when things go wrong, because they will go wrong, and don't, just keep at it. Yeah, and yeah, but be proactive as well. So proactive, curious, and persevere through things. Yeah.
Okay, thank you so much. It was so nice
You're
to
welcome.
learn from you.
I look forward to seeing what you create. So
Yes.
thank you for asking the question.
Bye.
Bye bye.
Okay, so now let us go to some participant questions that they were asking right now through the chat.
Yeah.
Um, if TFJS runs on the client side, then won't the processing be device dependent?
Correct. Yes, it is. However, we have support for WebAssembly and WebGL. So that means if they've got a graphics card, we can leverage that graphics card. If they don't have a graphics card, we can leverage the CPU, but in a very speedy way. WebAssembly actually has very nice execution on CPU. Even older devices can get a good number of frames per second on some of our machine learning models. So of course, it comes down to the size and efficiency of the model. But as we've shown with our face mesh example, that one that you saw my face being recognized with all the points on it, that runs on mobile and desktop and tablets, even on older devices, very, very nicely. So it is possible. But yes, you do need to be mindful of that, of course.
Yeah, a follow-up question on that that someone asked was, building a CNN model on TF Python can utilize most resources on a PC. So does using TF in the browser limit this capability?
What was the first part of that? Sorry, the CM model? Or?
Building a CNN model on TF Python can utilize most resources on a PC.
Oh,
Does using
CM. Okay, yeah, I understand now. Sorry.
yes, does TF in the browser limit this capability?
We've got convolutional neural networks running in TensorFlow.js as well. In fact, we've got various things like Coco SSD and all this kind of stuff, which are running very speedily, in fact. And you can even use transfer learning on those. That's how Teachable machine works with all the convolutional stuff. So this is totally possible and can run super fast on the web browser.
So the next question is, what is your process when you start a new project? How do you approach it?
When I start a new project, how do I approach it? So I guess most of the projects that I'm involved in at Google, at least in the previous roles, are completely blank canvases. So the first thing I need to figure out is, what am I going to do? So typically there's a problem, like a company would come to us saying, okay, we're going to launch this new product or service, and we want to know how to tell the story about that, essentially. What technologies can we use to tell that story in some unique way? So I go through an ideation phase of just whiteboarding ideas and arranging them into themes to understand commonalities between these ideas that I'm having. And then once those are on there, I work with my wider team to vote on the ideas based on everyone's different background and expertise. So maybe some ideas are more feasible. If I put time machine on there, maybe that's really cool, but not feasible. So you can actually plot on a graph like feasibility versus what other metric you want, essentially, time, cost, other things. And whatever the things that are the matter to your company or yourself, you can then spread these ideas on that graph in 2 dimensions and start to see the low-hanging fruit that you can actually start implementing. And from those, I'll cherry pick 2 or 3 that are good candidates, and I'll start prototyping those. And once I start prototyping, you'll have ideas that come from, as you're working with the code and working with those ideas, they tend to evolve naturally at that point. And you'll kind of, as a team, you'll end up going towards one or the other at one of those 3 that you chose. And that's the one you flesh out in more like an actual beta, maybe, and get user feedback and so on and so forth, and then go through the design sprints to iterate and that kind of stuff.
So I forgot to ask you a question. I wanted to know that how important is it to have a mentor or a guide in your technical journey?
I mean, it depends on the person. Some people are lone wolves and they like to just do things themselves. But I just be careful that you make sure you learn things the proper way and you're looking at the right resources to make sure the code that you think is excellent really is excellent, so that kind of stuff. For those of you who prefer to have a mentor, then yeah, definitely reach out to people, ask for advice is the best way to learn. And also for the mentors out there, it's the best way to learn as well. I've been asked questions by people who are completely new to, say, machine learning, and I'm like, oh, that's a really good question. I need to really think about that, because often you're working at a higher level and someone will ask, well, what does a convolutional neural network actually do? How does it do that? And how do I explain this to someone who's on like the beginning of their journey, and without just talking about these high level functions you can just magically call? And yeah, it forces you to learn as well as a mentor. So I do encourage for both candidates there, it's a productive experience, and do reach out to folk. Obviously, if you're reaching out to people, just be respectful of their time. Often they have other people also reaching out to them. So I would make sure you phrase the exact thing that you're trying to find the knowledge for in advance. Keep the kind of small talk small and make sure you get straight to the point in the question you want to ask. And they're more likely to then respond to you as well if you give the question up front than if you don't ask the question, just say, hi. No one's going to reply to hi on LinkedIn. So just put the question on there, and then if they know the answer, they can reply quickly. And if not, they can maybe point you to someone else who does know the answer at least. So yeah.
So I had a personal question. When do you start wireframing? Like, yes, you get the idea, and do you start immediately wireframing, or do you wait for the idea to like you think it's feasible and then you start wireframing for it? And what do you
For me,
use?
yeah, I go straight to HTML5, CSS, and JavaScript because that is my wireframing. Those divs and things and paragraph elements and headers, that is my box. So I don't need to use wireframes because HTML and CSS give me that for free. So essentially I go straight into prototyping, and often for my previous role, I had to produce these prototypes, sometimes in less than a couple of days in order to reach the deadline. You get fast at doing this once you're proficient in using CSS and JavaScript and HTML. So yeah. But of course, if you prefer to use a tool that allows you to prototype, whatever feels comfortable. I'm not forcing that upon people, of course. Do what feels right for you, but do also try my method out as well. You might find that if you are a skilled web developer, that's actually faster than tinkering around in Photoshop or something. Yeah.
So the next question is from the chat. Can you recommend some more books to learn deep learning, AI, machine learning, or data science?
That's a good question. I don't have like a whole list to mind right now, unfortunately, but what I can do is I can follow up on LinkedIn and Twitter with some recommendations. There's a few courses that I'd recommend. Some of our community members have made some great courses for TensorFlow.js. Some of you may know Lawrence Moroney, who has made some courses as well for TensorFlow, but also covers TensorFlow.js as well now. He's got a few courses talking about TensorFlow.js too. I can put those links up on my LinkedIn and stuff in a couple of days maybe. Yeah, please, whoever asked that question, please message me on LinkedIn or Twitter to remind me to do that. And I'll happy to go around the team and ask everyone for their top pick, and we can all give our top picks.
Yeah, so one more question. Any beginner-friendly ideas specifically to start with TFGS and Node if we don't wish to run ready-made models like body picks and etc. and learn it from scratch?
From scratch, the best way is to use the Deep Learning with JavaScript book that I mentioned earlier. That starts with the most basic models, like a simple linear regression, one-dimensional, very simple. And then it works its way up to like a multi-dimensional linear regression. And then it goes to non-linear regressions. And then it goes to CNNs, so convolutional neural networks. It goes to GANs. It covers everything that you'd want to know, honestly. Yeah.
So what basics what prerequisites does one need to go to that book?
Just some basic working knowledge of JavaScript. You need to understand like functions, objects, all the kind of some of the new syntax that you might have seen in the newer versions of JavaScript that are now more popular, the arrow syntax and promises, await, that kind of stuff.
Yeah.
assuming you know the basics of the language. So first take a course on JavaScript if you aren't familiar with JavaScript. Once you are happy using JavaScript and the related CSS and HTML, then pick up that book, and it's very easy. It's written for beginners, which is great.
So there's one advanced level question asked by Darshan. He has asked, TFJS usually requires splitting of image data, which is really inconvenient for pre-processing. Also, libraries like ML5 can do this but lack layer support. So what is the best way to load image data for custom training?
Loading image data because is this in the browser or on Node, or does it not say?
Darshan, can you specify?
Okay. So we actually have a few code snippets online on how we train things for our things like Teachable machine, where we retrain that in the web browser. And there's some code on codelabs.google.com which walk you through how to load in the image data and all that kind of stuff. I think we actually use some third-party libraries that are just popular, kind of like you would in Python. You use like various Python libraries to handle CSV files and all this kind of stuff. So the same kind of libraries exist in JavaScript that can do like CSV file manipulation or loading of image data from sprites and all this kind of stuff. So all of these things are possible in JavaScript too. You just need to find the libraries there. But if you take a look at some of our examples on codelabs.google.com and search for JS at the top to get the TensorFlow.js tutorials, you'll find some there that talk about image specifically. That goes into more detail there. That would help you out.
So I'm really passionate about open source, and I really love open source. So someone was asking that how can a student contribute to some AI or ML repository? Like, because it's very difficult to find something, and it's not as the barrier into AI is quite higher than it's into
Sure.
web. So how can a student contribute?
Yeah, so in addition to contributing to the core TensorFlow.js, which is obviously much more low level and you need to have a good solid machine learning understanding to really affect anything in that repository, we also have on the same repository subfolders for demos and things that are using our models or maybe your own custom models that you may have made from your learnings. And we welcome contributions there as well to help kind of inspire people as well, I guess. So we have a big list of inspiration and demos on that GitHub repository too. And those, of course, are welcome to be submitted by all. And of course, if you want to write tutorials and help us with documentation, I'm actually the only developer advocate for TensorFlow.js globally right now. And I'm always happy to have extra hands or words or fingers being written online. So when people are searching for tutorials, maybe you can write it in a way that makes more sense for someone from the background that you come from. So maybe you're a musician or an artist and you're writing in the context of that mindset. Having more blogs and things talking about this stuff is always great. And it showcases your knowledge of the area, which is great. People might find you thin because of that. So it's a kind of a win-win situation. The community gets better and you might be noticed for it too. So, yeah.
So maybe we are falling short on time. So now I'll request everybody to send requests to Sona on LinkedIn if you want to ask any more questions. And do not forget to mention a note when you send the request. That is how we met Sir online and we called him for this.
Oh, 1 second. I'm just going to share the tab in case you didn't get it. These are, I'm just going to end with this. Can you see the screen? So this slide here has a ton of links if you want to get started. There's our website, an API which you can reference very easily here. There's our models repository for all the models and more that you can find on this link. Our GitHub code is available on this link. We've got a Google group for more technical questions that our team monitors, including the software engineers on our team. And we've got boilerplate code available on CodePen and Glitch. And of course, here's the book. So if you want to take one screenshot today, this is a great screenshot to take to remember to go to. I can also send these around if you forget. And then finally, if you want to connect with me, I'm available on Twitter and LinkedIn using these two links as well. And I'll hand it back to the presenters to wrap up, I guess. Thank you.
Yeah, so please do share these links with us. We would love to share it with all of these people.
Yeah, I will do.
And this is basically the end of the session. So I think Anushka will give the vote of thanks.
Yeah. So thank you so much, Jason sir, for talking to us in an informal and a friendly way at midnight. I know it's 2 o'clock there.
1 a.m. now over in San Francisco.
Thank you so much, sir, for cooperating, and thank you to all the teachers who are here for supporting us, and our friends who are taking away something very important with them, I'm sure. And thank you to our Unfolders team to giving us an opportunity to be here and talk to sir. So we'll be unfolding our next unfolder very soon. So stay excited the same way and to be a similar session. And we thank you, Jason sir, once again.
Yeah, and
Well,
there's a
thank you for having me.
feedback form that everybody should fill. We'll share it on the. It's already shared on the chat, and we share it on the WhatsApp group as well. So thank you everybody, and thank you, sir. Thank you so much. We really appreciate you.
Awesome. I think one person asked if it was recorded. Is this going up live anywhere afterwards, or?
I guess the ideators could answer that.
No, this session is not.
Okay, good to know. Thank you. Cool. Thanks, everyone. See you. Bye-bye.